Hey everybody, this is Kyle with Method Learning, and today we're going to look at some of the questions from the SAT Digital Practice Test number 1. They have released 4 digital adaptive practice tests so far, and they've released 4 kind of traditional paper and pencil non-adaptive tests. And we're going to look at some of the questions on the non-adaptive paper and pencil test here. Maybe you've already looked at this, maybe you haven't, but we're just going to go through them and see how quickly we can get through this. I haven't looked at this test yet, just so you know. And we're going to see first how quickly we can get to all the answers. And second, and maybe just as importantly, is how we can use this new built-in calculator Desmos for answering as many questions as we can. So without further ado, let's get into it and see what we can come up with. So first one, we want to figure out 10% of 470, and all we have to do there is change 10% to a decimal, so 0.1 times 470, and if we do that on a calculator, we're going to get 47. That was easy. That's our first answer. Number 2, which equation has the same solution as this one that they've given us? 4x plus 6 equals 18. And if we start solving this right away, we can minus 6 from both sides, and we get 4x equals 12. Let's stop right there, because that equation is one of the answers, and those are going to have the same solution. So the solution would be 3. If you go back to the original question, plug in 3, it's going to work for that one too. So that would be the next one. Here we need to write an inequality. So it says there's a $25 service fee. Seems like that's like a one-time fee that you just pay one time, hence the name one time. And then the $10, it says per hour rental fee. So that's where we're going to multiply that per hour by T. T is the number of hours. And so, for example, if there's 3 hours, that'll cost $30. If 5 hours, it'll be $50, etc. And we're going to add that to the $25 service fee, which is just that one-time cost. And we know that that has to be, well, let's see, a maximum of $75. So altogether, that's going to be less than or equal to 75, which is what maximum means, no bigger than 75, less than or equal to it. And that corresponds to the answer in D. Even though they wrote these backwards, that's okay, we can add in any order. So we get D for that next one. Number 4, for which value of x in this function is g of x equal to 25? So if g of x is 25, we can go back here and plug in 25 in place of g of x, giving us 25 equals x squared plus 9. And if we solve this, we're going to subtract 9 and get 16 equals x squared. And if we square root 16, we're going to get 4. The next one, this is probability. 14-sided die, 1 through 14, and we want to know the probability of rolling a 2. So there's only one 2 on that 14-sided die, and so that would be our numerator. There's one chance of getting this 2 out of the total of 14, because there's 14 sides, and that gives us our answer A. The next one, printer produces posters at a constant rate of 42 posters per minute. At what rate in posters per hour does the printer produce the posters? So 42 per minute, another minute would be another 42, and another minute would be another 42, etc., all the way up to an hour, which is 60 minutes. So we could just do 42 times 60, and maybe we can use a calculator here. We'll go to Desmos, 42 times 60, and there's our answer, 2,520. So we would fill that in on our answer sheet, and that would be the final answer for that one. Next page, that was pretty quick, maybe a couple minutes for that page. Number 7, the function f is defined by this equation here. We want to know the value of f of x when x is 4. So if x is 4, that just means plug in 4 in place of x in the function, gives you 28 plus 2, because 7 times 4 is 28, and that'll be 30. That's our final answer. Number 8, this assignment's worth 70 points, and it's made up of 1-point questions and 3-point questions. They tell us, and this is important, of course, x goes with 1-point questions and y goes with the 3-point questions. So we're going to do, we could say 1 times x, that would be the total number of points for however many 1-point questions there are. And then if we add that to 3 times y, this here is the total number of points for all of the 3-point questions, right? If y is, let's say, 6, that's worth 18 points, 3 times 6. So that would be the total number of points, 1x plus 3y, or just x plus 3y. And we know that the assignment is worth a total of 70 points, so this will equal 70. And that would be our answer, and that's D. What about number 9? Okay, we've got 2 right triangles. They're similar, and it says L and M correspond to P and Q. So, okay, all of those angles are kind of matching up in the order that they say. L goes with P, M and Q, N and R. We're used to that if we've ever seen similar triangles. And it says that angle M's measure is 53. What's the measure of angle Q? Well, if these are right triangles, obviously one pair of the angles is 90. And if the other angle is 53, well, that means you could maybe see pretty quickly that the answer, I shouldn't jump to that yet. Why don't we draw these out? Okay, we'll draw just random right triangles that are hopefully similar to each other. Doesn't really matter how perfect we draw them. But let's say that this is angle M, and that's 53 degrees. And then if that's M, then we have L and N also. So why don't we say this is L and this is N? Okay, that's L, M, N. That works. And this must be P, Q, and R because remember those letters have to pair up with each other. L, M, N, and P, Q, R. That's the order that matters. So angle Q is also 53. And you know what? We didn't even have to do this all out. I wasn't checking the numbers or the letters well enough. Remember, M and Q correspond to each other. They go together. And in similar triangles, those corresponding angles that are in the same place, they have to have the same angle. And so if M is 53, then Q is also 53. That was easy. We took a little longer than we should have on that one. What about number 10? This is the first one that we can use Desmos for. So we've got a system of equations. Remember, a system is just 2 equations. In this case, they're both lines. And if we type them both into Desmos like we see them, you can see that the first one gets graphed there nicely, negative 3x. The next one, 4x plus y equals 15. There, you see that one. Now, you might look here, and I know my video is blocking this, but they don't intersect. And remember, a solution for a system is the intersection point where the lines or the graphs cross each other. But they don't intersect here, so what do? Well, we can just move this graph in Desmos down. We can see that they're getting closer and closer, and eventually they are going to intersect. And the nice thing about Desmos is you can go to the point close to where it looks like they're intersecting, and you can just hover over it or tap it, and you can see here that that's the intersection point. And because they specifically ask for the value of x at that solution, that would be 15, right? 15 is x, negative 45 is y, giving us an answer here of C. What about number 11? So this one's actually pretty simple because we look at all the answers and they need the line, the equation for the line of best fit. So remember, a line of best fit is just a line that roughly approximates, that was pretty bad, but it goes through the center of all the data points and it approximates all the data. Well, here notice that all the answers have the same numbers. It's just some are positive and some are negative. And this is in slope-intercept form. All of these answers, y equals mx plus b, that's slope-intercept form. M is the slope, b is the y-intercept. Well, take a look at our picture. It's obvious that the y-intercept is somewhere up around 10 or 11. Apparently it's 10.1, but is it positive 10.1 or is it negative? Well, clearly it's positive because it's up here in the positive y area. So that already gets rid of A and C, which have those negative intercepts. Those are bad answers. And then finally, the only difference between B and D is that the slope, 1.9, is either positive or negative. Well, remember, if a line goes down like this one, from left to right, it's going down, it has to have a negative slope. That's simple. So who cares where the 1.9 comes from? It doesn't matter. The answer has to be B because it has a negative slope and a positive y-intercept. Pick it and move on. What about the next one? Number 12. So we've got a really messy looking problem here, but this one's actually pretty easy because it says, for how many values of x does f of x, that function, equal 0? Well, when f of x equals 0, that's another way of saying that y is equal to 0. Remember, f of x and y are interchangeable. They mean the same thing. So if y is equal to 0, where would that be? Well, y is always 0 on the x-axis. And so the question basically is asking you, how many times does this graph cross the x-axis? And we've got 1, 2, 3 places, and so the answer is simply 3. So don't let that confusing, intimidating looking problem mess with you. It's actually rather simple. What about the next one? Vivian bought party hats and cupcakes for $71. Each package of party hats was $3. Each cupcake was $1. She bought 10 packages of party hats. How many cupcakes did she buy? Okay, this one's easy. 10 packages of party hats, and each package was $3. 3 times 10 gives you a total of $30 for the party hats. Now, you know that she spent $71, and all that rest of the money must have gone towards cupcakes. So if you take 71 and you minus the 30 that she spent on party hats, you get $41. And because each cupcake was exactly $1, that must mean she bought 41 cupcakes. Simple. What about this one up here? What is one of the solutions to the given equation? So here it's a fill-in-the-blank type question. You got to come up with your own answer. And for a quadratic like this, there's usually going to be 2 solutions typically. And so we could actually go to Desmos. This is the second one we can use Desmos for. And let's, by the way, you could click this home button and it'll rescale it and take you back there to the origin. That's kind of nice. And if we type in, I'm gonna change z to x. Okay, so x squared plus 10z, or 10x minus 24. And if we zoom out, you could see that we got our nice quadratic, our parabola, the curve. Now a solution, remember, to a quadratic is just an x-intercept. So if we zoom in to find the intercepts, we get 2 of them. We've got -12 and we've got +2. Take your pick. You could pick either one of those for the answer. If you put -12, you'll get it right. If you put 2, you'll get it right. They just want one of those. How about number 15? So 300,000 cells to start with, and the number of cells doubles every 3 hours. How many cells will there be 15 hours after the initial observation? So you might notice that that means that it's going to double 5 times because there's 5 3s in 15, right? 15 divided by 3 is 5. So it's going to double 5 times. You could think of it that way. You might just want to take out your calculator or do this in your head, take 300,000 and just double it 5 times. The other way that you could do it is you can take 300,000 and you can multiply it by 2 to the 5th power. If you know exponential functions, if we double something 5 times, we're just going to multiply by 2 to the 5th, which is 32. So if you do any of those methods that we just said, 300,000 times 32 is going to give you your answer of D, 9,600,000. Okay, what about 16? We've got exponents. Which expression's equivalent to this thing? So first thing I notice is we can't combine these because they don't have the same exponents. So we can't just say, oh, 18x something. We can't do that. They're totally different. But what we can do is we could factor something out of both of these. And you could see in all the answers that they've factored something out, meaning we've divided it out of both of those original 2 terms. And so we can divide out a 6 because both of them have a 6 in common. We can't take out 12 from both because this first one doesn't have enough to give, right? The maximum we can take out is those 6. And then the same with the x's. The most x's that we could take out of both of them is 2 because we're limited by this one, which only has 2. And then of course both of them have, both of them have 2 y's. So we can take out both of those y's from both. So we could factor out 6x squared y squared. Now, no surprises here. All of the answers have that factored out. So maybe we should have not done all the math out, but that's okay. The question is, what are we left with when we take that out of both expressions if we divide it out? Well, let's look at the first one. If we divide out 6, we're going to be left with nothing, so really just 1, right? 6 divided by 6 is 1. If we started with 8 x's and took out 2, we have 6 remaining. Just subtract. And if we started with 2 y's and took them both out, we don't have any y's left. So the first term in the answer in the parentheses will be x to the 6th, and already we see that C must be the answer. If you want to see where the 2 comes from, this term divided by this just leaves you with positive 2, right? 12 divided by 6 is 2, and then the x squared and the y squared both get factored out, so we're just left with those 2. So the answer is C. let's keep on going. Number 17. Let's see. There's a 2-hectare park. That's just like an amount of space, like acres, and 35-hectare residential area in this neighborhood. The total number of trees is 3,934. And this equation, 2x plus 35y equals 3,934, represents the situation. They say, which of the following is the best interpretation of x in this context? So that's a little bit tricky. So of course, x we know goes with 2, which is the 2-hectare park. And so we know that the answer must have something to do with the park and not the residential area. Again, because x goes with the 2, and they're asking us about the x. So because the 2 goes with the park, hopefully you can see where this is going, it's not going to be anything having to do with the residential area. So cross out B and cross out D. The question is x the average number of trees per hectare in the park or the total number of trees in the park? Well, it's not going to be the total number of trees in the park. And here's why. Because let's say that there were, 100 trees in this park overall. Well, 2 times 100 would be 200, but we know that the total number of trees is 100, right? So it must just be the average number of trees per hectare. And then if we multiply by 2, which is the number of hectares, that's going to give us the total number of trees in the park, which is what we really want in this equation, right? Because if you think about it, this number, 2x, whatever it is the total number of trees in the park. 35y is the total number of trees in the residential area. And if we combine them together, we should get the total number of trees in the neighborhood, which is exactly what they said that this number 3934 represented. So the units are pretty important there. Think through it like that. It's very tricky. That one's probably the hardest we've seen so far. It's starting to get more difficult, as you can see, but we were able to figure that one out with not too much trouble. All right, the next one, 18. Let's see. The graph shows the relationship between the number of shares of stock from company A, X, and the number of shares of stock from company B, Y, that Simone can purchase. Which equation could represent this relationship? Okay, so what I would do is this is a good question. What I would do is I would look at a point on the line, for example, this point up here. That point corresponds to the coordinates 0, 40. X is 0, Y is 40. Okay, that's pretty easy. And if the number of, so really, if this point's on the line, that means that we should be able to take this point, X being 0 and Y being 40, and plug it into the answers. And there should be, it could work in multiple equations, but we know that the answer has to have that point work in it, right? Because that point's on the line, so it must work when we plug it into the equation. So for example, if we plug it into A, 8x plus 12, well, Y was 40, so that's going to give us 40 equals 8 times 0 plus 12. That makes no sense. 40 does not equal 12, so A can't be the answer. And if you do this through all the answers as well, you're going to see that C doesn't work because 40 doesn't equal 0 plus 8, which is 8. So C's out. So it's either B or D. Now, if we take this point, I bet you that, I can already see. There's only one of these that's going to work. So if we try it in D, I want to show you why this is wrong and B is the answer. If we do the same thing, we should get 12 times 0 plus 8 times 40 equals 480. And we're going to check, is this actually true? Remember, we need it to be true because that point's on the line. So we get 0 plus 320, which is 320, which is not 480, which shows why D is wrong. B, if you try it, it's going to work with that point. And I just want to emphasize, we could have picked any point on the line. I just picked this one because it had easy numbers to plug in. I love working with 0. 0 makes the math easy. You could have easily picked this one down here, which would have been 60, 0, and you would have been able to plug that in. And if you plug it into B, that will also work. So pick a point, plug it in. I like that strategy because it makes the math pretty easy and you don't have to think through the different scales and how to make the equation of the line. Okay, so that's 18. What about 19? Circle A has a radius of 3n. Circle B has a radius of 129n, where n is a positive constant. The area of circle B is how many times the area of circle A? Okay, awesome. So it turns out that it doesn't really matter what the value of n is here, but we can certainly put in a value for n that we choose just to see how the math works out. So what I mean by that is, what if we just say, well, n is going to equal, I don't know, 2. So if n is 2, then circle A has a radius. Let's say the radius r sub A, r of A, the radius of A would be 6, right? And the radius of circle B would be double 129, which is, I guess, 258. You can check me on that if you want. Now, the area formula for a circle is pi r squared, right? And we could actually see that if we go back to this reference sheet, which the SAT gives us. We've got right here the area of a circle, pi r squared. So if you didn't know that, now you know. So what does that mean? It means that we can find the area of the first circle by doing pi times 6 squared. And the second circle, we can do, I shouldn't put equal signs, but anyway, pi times 258 squared, right? Now, notice both of these have a pi in them, so that's going to kind of be irrelevant. At the end of the day, those are going to kind of essentially cancel each other out because they both have a pi in them, if you want to think of it like that. So the important part is that the bigger one is 258 squared, and we can go back to Desmos and we can try out 258 squared, and we get that massive number, 66,564. And if we do 6 squared, that's easy. We get 36. So the question is, how many times bigger than 36 is 66,564? So we can actually take those two, and hopefully you know that we can just divide them. And if we do that, we get 1,849, which is going to give us our answer of D. Now, where does that number come from? Just to talk about it. 129 times, or divided by 3 is, I think, 43, right? 129 is 43 times bigger. And the radius is 43 times bigger. But if we have our area formula where we're squaring the radius, then we're just going to square this, this number 43, and that'll show us how much bigger the area is going to be of the bigger one, if that makes sense. Okay, so anyway, we get D, 1,849. What about number 20? Man, I haven't looked at this. I don't even know how many questions there are. 27? All right, we're making good progress. So number 20, here's a frequency table. What's the maximum data value in the data set? All right, these are tricky for a lot of kids, a lot of students, but this is how you read it. So these are the different values in the data set, from 6 all the way up to 14. And the frequency column tells you how many times that number appears. So if we had all these data points written out in a list, it would have 3 6s, so it would be 6, 6, 6, and then 3 7s, like this. But then there's 8 8s, so there would be 8, and you get the idea, right? There's going to be 8 of these, etc., etc. Now you could see why they don't want to write it out like that. It's a pain in the butt. However, we should now be able to figure out what's the maximum data value in the data set. Well, this is actually easy. You probably didn't even need me to say all that, because the data values are in this column, and the biggest one is simply 14. So the answer would be 14. There happen to be 6 of them. You might need to be careful because I notice that there's a 0 here with the 13. So just be on the lookout if you see a question like that, because if they had put the 0 in the 14 place, then that would have meant there actually weren't any 14s in the data set, and it would have been the next lowest one. Okay, so just be aware of that, but the answer here would be 14. 21, we've got a circle, a diameter with these endpoints. An equation of this circle is this. Okay, cool. What's the value of R? All right, so I'm trying to think, can we do this in Desmos? I'm pretty sure there's a way that we could do it. Let's play around in Desmos. This is going to be good for me and for you. So let's see what we can get. We've got x minus 2 squared, and then we've got plus y minus 9 squared equals, now it says r squared. So here's where we don't know what r is, right? But check this out. This is really cool in Desmos. They give you the option to add a slider, which means, hey, there's this number that we don't know. Let's see what it could possibly be. So you see, if r is 1 in that equation, then this tiny, tiny little circle up here is the circle. But remember, our circle has to go through and have endpoints for our diameter of 2, 4 and 2, 14. So we could actually put those in Desmos and have it label them for us. And all we need to look for now is a circle. When we move this r, look what happens. If I drag this r value, the circle changes. So I want to pick the r value that makes that circle have its circle be on those points, if that makes sense, right? I kind of said that weird. But what r value would do that? And you could see that it would be 5. Okay, so even if you want to zoom in just to confirm, you can see that this gives us an r value of 5, where this diameter, remember the diameter is the segment through the center of the circle that connects two different points on the circle, right? And so you could see that the diameter would be exactly as they describe it, from 2,4 to 214, and the answer would be 5. Okay, now one thing I want to talk about in Desmos real quick while we're here is if you have a slider like this, if you tap on any of these endpoint numbers, -10 or 10, you could actually change the range of that number r. So instead of going from -10 to +10, if you needed bigger values, you could just change it to be from maybe -100 up to +100. And you could change the step as well. It didn't look like it was going to let me there. Oh, it's down here. So the step is just how many, what are the increments, right? Each one goes up by how much. And if you want to just make it be whole numbers, you can make it have a step of 1. And most of the time, the answers on the SAT are going to be whole numbers, so you can usually get away with that. But if you find that the whole number answer doesn't work, then just change it maybe back to 0.1 or 0.5 or some kind of decimal, okay? And now you could see if you hit enter, that now I can move this to huge r values, which really quickly go off of our screen. But 5 is going to work. You could actually see here, surprisingly, not surprisingly, but I don't know, that -5 also works. Why is that? Because if we square -5, we get 25, which is what we have here, r squared. Now, notice you can't put -5 as your answer because they specify r is a positive constant. So I overlooked that. So it's definitely 5 as an answer. It's just interesting to see that -5 you could also square. Okay, and we knew that. Anyway, I'll stop talking. Let's go to 22. We've got angle r is 2 pi over 3 radians. Angle t is 5 pi over 12 radians greater than angle r. And we want that angle's measure in degrees. So first we have to figure out what angle t is in radians, and then we have to convert it to degrees. So angle r is 2 pi over 3. Angle t is 5 pi over 12 greater than that. So we have to add those two together. And we need a common denominator, which will be 12. If we change this to being out of 12, I have to multiply the 3 by 4. Let's multiply 2 pi by 4, and we get 8 pi. So 2/3 pi is the same as 8/12 pi. That should be easy to see. And if we add that to 5 pi over 12, we're going to get t's measurement, which is 13 pi over 12. And that's just a little bit bigger than 1, right? 13 over 12 is just a little bit more than 1. And if you know your degrees and radians, remember, 1 pi is 180 degrees. So pi is 180 degrees. Now, if we have something a little bit bigger than 1 pi, 13 pi over 12, we're going to just be a little bit bigger than 180, which shows us that the answer should be 195. It's the only one that makes sense at this point. If you didn't like that, you want to know the real reason why mathematically, well, that is the reason. But how could you figure it out? You could take that number, 13 pi over 12, and you can convert it to radians by multiplying by 180 over pi. And it comes from this relationship that I already mentioned. How do I know that the pi goes in the denominator? It's because I'm trying to cancel out the pi's to get out of radians and into degrees. So by putting the pi in the denominator, it'll cancel with this one. And then I get 13 times 180, which I don't want to do out, and then divide it by 12. So I could actually divide 180 by 12 first, and that'll give me 15. Yeah, 15. And so I end up getting 13 times 15, and 13 times 15, if you do it out, I'll just show you right here. 13 times 15, and we get the same answer as before. I don't know if you saw that, 195. So 13 times 15, 195, that's the number of degrees, and we get C. What about 23? A certain town has an area of 4.36 square miles. What's the area in square yards of the town? Ooh. So we have to maybe go from square miles to, how are we going to do this? Let's talk about it. So if we have a square let's just draw in a square. Let's say that, whoops, that's a rectangle. So that is, let's say, the town. Now, it doesn't matter that the town isn't necessarily a perfect square. This is still going to work because the area is still in square miles. Okay, I'll just say that first. So if the area is 4.36 square miles, that means that we could find the side length of a square of the same area. So how would we do that? Well, let's clear all this out. And we can take the square root of 4.36. And if you do that on the calculator, you get about 2.088. So that means that if we had a square that represented this town, each side would be 2.088. And that would be in miles because the original units were square miles. So now we've got our miles of this square, but we don't want it in miles, we want it in square yards. So how do we convert from 2.088 miles to yards? Well, if a mile is 1,760 yards and we've got a little more than 2 miles, we should just take our 2.088 and we should be able to multiply it by 1,760. So if we do that, if I take this and I multiply it by 1,760, there's our answer. Well, it's not our answer yet. That's the number of yards on this square. So let's go to maybe a different color. And this square we could see is now 3,674, we'll say point, I don't know if we need to round this much. We'll just say 0.99 yards. And that's the side length now of this square. So we converted that number of miles, 2.088, into yards. So we don't need that anymore. Let's get rid of it. Finally, we don't want this in yards. We want it in square yards. So we need to find the area of this square now that we've converted to yards. And so, of course, what we can do now is we can just take that number, 3674.987. I'll just go off of this one up here. And if we square it, because that's how you find the area of a square, you square the side length, we're going to get this really big number, but you can see that that matches up with what it says in D. 13,505,500, they say 36. We've got 529. It's close enough. The reason for that difference is because of the way that we rounded versus them. That's okay. Clearly, this is the closest answer, so the answer would be D. Okay. What about number 24? We've got a table, 3 values of x and their corresponding values of y. And this is for line H. So line H is the one shown in the table. Line K is the result of translating that line that we see in the table down 5 units. And then they say, what's the x-intercept of line K? So we've got a couple things that we need to do. We need to find maybe the equation for this line from the table, maybe put it into Desmos, and then try to shift it down 5 and find the x-intercept. So there's a couple ways we could do it. I think that the way I just said is going to be helpful. So we've got x's and y's. We can find the slope of the line, and we could find, let's just do that. I'll stop explaining and I'll just do it. So the slope is, remember, y2 minus y1 over x2 minus x1. So if we could pick any of these points in the table. These are all points, x and y. Why don't we pick those first two? y2 minus y1, we'll say 160, the second y, minus the first one, 130, over the same with the x's, 23 minus 18. We're going to get 30 over 5, which is 6. And so the slope of this line is 6. So it would be y equals 6x plus something. Remember, the slope goes in front of x in y equals mx plus b. Now, what would be the y-intercept? Well, we can continue this equation and just say, well, we don't really know what the y-intercept is. Let's call it b. And we can take one of these points, x being 18 and y being 130, and let's plug it into this equation here. So 130 is y, and that should equal 6 times 18 plus something, which we're calling b. And now we can solve this for b to get our equation, or at least the y-intercept. And so 6 times 18 is, I think, 108. And 130 equals 108 plus b. And if we solve for b, b is going to equal 22. Okay, so the x or the y-intercept of this line is 22. That's going to go in this place up here in the original equation. But remember, this is line H. Okay, so line H's equation is that. So let's go over to Desmos and let's just start by putting that in. So let's go home and let's type in y equals 6x minus or plus 22. Okay, that's the line H that they mentioned. Then they say that line K is found by translating, that means shifting line H down 5 units. Now, there's a lot of ways that you can do this, or at least a couple. But one of the ways that you can do it is you can take the y in the original equation, and if we're going to shift it down 5, then that means that we can change the y, right? Just like if we had an equation like, let's go to like a random quadratic, right? So x squared. If we had y equals x squared, and I said, take that and why don't you move it down 5? Well, you would just slap on a negative 5 at the end, right? Or if you wanted to move it up 5, you would just put plus 5. So we can do the same thing here. I might not have said this a minute ago, but we should just be able to take this original equation, and in order to move it down 5, we should just be able to go like this. Literally just put minus 5 at the end. Okay, let me do that again. Let me keep this here, and let me make a second copy of this line. And if I put minus 5 at the end, oh look, you could see the black one is the shifted down 5 version. And you could confirm that because the original intercept is 22. The new one is 17. Boom, it got shifted down 5. So all we do is put minus 5 at the end. Of course, this would become 6x plus 17. That's the same thing, 22 minus 5, right? But what do we do now to find the x-intercept? So we've got our new equation, y equals 6x, remember I said it's really plus 17. That's our equation, but we need the x-intercept. So I guess what we can do is we can go in Desmos. The black line is the one that we care about now. And we can zoom in and try to find where it crosses the x-axis. And it's going to be at this number here, negative 2.833. So if I write that down, negative 2.833, that should be our answer. The question is, which of these numbers corresponds to that? And it looks like if you do these in the calculator, yeah, the answer must be D. So why is it D? Well, D is the only one that's even in the 2's. It's negative 2.8. 6 goes into 17 twice with a little bit left over. Of course, we can type this number, negative 17 over 6, into Desmos, and sure enough, there it is. It matches with that number we just saw for the intercept. So that would be the answer. The other way that you could do it, just at the very end here, once we got the equation, if you didn't think to look on Desmos, which would be pretty silly, but if you didn't think to look there for the intercept, anytime you want to find an x-intercept, all you have to do is plug in 0 for y. Why? Notice that all of the x-intercepts in the answers have x or y values of 0. So if you notice that, you can take the equation, plug in 0 for y, and you could solve for x and get the x-intercept. So if we do that here, we'll get 0 equals 6x plus 17. And if we move 17 over, negative 17 equals 6x. Divide by 6, and there's that number. X equals negative 17 over 6, and that would be the answer in D. All right, on to number 25. Before we get there, let's just clean this up a little bit. So actually, I don't think we're even going to need to make all that room. This one looks like we can do it in Desmos. So these two equations, negative x squared plus 9x minus 100 and y equals c, they intersect in, it says in 1 point. So this is hard to do without Desmos. It's doable, but you're not going to want to do it without Desmos. And we get an easy answer is the best way I could explain it in Desmos. So you don't see it there. You might need to zoom it out, but there's the quadratic or the parabola upside down, right? And y equals c, any line that's y equals a constant is a horizontal line. So if we do y equals c, this is the problem with the Desmos on this one, and I'm going to show you a workaround for it. But if we put y equals c, notice it doesn't say, add a slider like we were hoping to do to find the value of c. We actually have to figure out that there's no x in this equation, which means there are 0 x's, and so we could actually play around with it and put 0x plus c in there. Because isn't that the same thing as y equals c? So if we do it like that, now we can add a slider, And now we've got our horizontal line. And notice that the range of C isn't going to work here because it's not going down to the parabola. Remember, we want these to intersect in one point. So let's do that trick we mentioned earlier where we change the range of this, maybe from, I don't know, -10 up to like 100, because I think I need it to be a positive, positive number. We'll do a step of 1. That should work. And, oh, that's the wrong direction, right? We need, I guess, negative C values. Whoopsies. -100. And now I can move this down. And let me zoom in just so we could really see where they're going to intersect in that one point, which is right here. But you might even be able to see right away that in order for that line to reach all the way down there, guess what my value for C has to be? It has to be that number there, -79.75. That's the Y value. So check it out. If I go down there, you could see that it's getting close to intersecting at one point, but it's not. That's because my step here is 1. It needs to be a decimal, but I don't really need it at this point because I know that in order to intersect it in that one point, it has to be that point at the very top of the parabola, the vertex. So the Y value is going to be -79.75. The question now becomes, which of these fractions is that? So if you don't know, I don't know, it's either A or C, I guess. Just divide them in Desmos. So -481 over 4. Oh, that's too big. It's 120. It must be C. So here's why. -319 over 4. Boom. There's that number we just saw here, -79.75. And so the answer for 25 would just be C. All right. How about number 26? We've got only 2 more questions. For each real number R, which of the following points lies on the graph of each equation in the xy plane for the given system? This is a good question. However, first thing I noticed, and maybe this isn't going to help, but I noticed it anyway, is that both of these equations are actually the same line. Now, you might, let me take a sip of water. You might say, well, how the heck do you know that? Well, take a look at those equations, and you tell me what you think. One of them is just a multiple of the other. So this first equation, if you just took it and multiplied everything by 5, you're going to get the second equation, right? Distribute a 5 through the whole first equation, and you're going to get the second one. So that means that these two lines are the same. I can prove it, of course, in Desmos. 2x plus 3y equals 7, and 10x plus 15y equals 35. Watch, they're going to overlap. Boom, there they are. See, they're the same line. See, blue one's there, the green one was just there. So they're the same line. So really, we don't need to worry about both of these lines. We could just maybe focus on one, knowing that they're exactly the same. Okay, so let's just, I guess, cross out the second one and just worry about the first. Now it says, for each real number R, which of the following points lies on the graph of this one equation in the xy plane? So how could we figure this out? Well, I don't know. Let's play around with it and let's see what we can come up with. So it should work for any value of R, of course. And why don't we just pick a number for R? Because if it works for every real number R, we should be able to pick any number we want and get different points in the answers, and we could see if they're on the line. So why don't we just pick R equals, why don't we say, let's pick a number that can be divisible by 5 and 2 and 3, which would be 30. Let's do that. So 30 works. So if I pick 30, R equals 30. Then that first point, maybe I'll move this up here. R is 30. That first point is going to be, let's see, 30 divided by 5 is 6, and 6 plus 7 is 13. And then negative, well, 30 over 5 is 6, but it's negative. So negative 6 plus 35 is 29. So if, is that point going to be on the line? Let's see, 13, 29. Well, if I scroll over here, over to 13, you should hopefully very quickly see that 13 is over here, but it's not up to 29, right? It's 13 and negative 6. So that just means that A is the wrong answer. Okay, what about B? We can do the same thing here. So R is 30. So we've got 3 times 30 is 90, and 90 divided by 2 is 45. So that would be negative 45. And then, oh, plus 7 over 2. So that would be plus 3.5, which is, this is a pain, but this is negative 41.5, I think is the right answer. And then R is 30. Okay, cool. Let's see if that number is on the line, or that point. I could even type it in here, negative 41.5, comma 30. Let me go over here, and oh, shoot, look at that. That's on the line. So that's actually going to be the right answer. And I know it's the answer because I picked such a random R value, 30, that, and it still worked. So that one must be right. If you want to check C and D, have at it, feel free. You're going to see that they're not going to be on the line, but that's probably the best way to do that one. Again, I haven't seen this question before, so I'm sure there's a faster way. Let me know in the comments if you thought of a way to get it faster, but that would be a good way to get to the answer we get B. And finally, 27, the perimeter of an equilateral triangle is 624 centimeters. The height is k root 3. K is a constant. What's the value of k? Okay, let's draw an equilateral triangle. We don't need to make it perfect. That's okay. Actually, let's make it perfect. So we'll do this. Yeah, that works. 60 degrees is an equilateral triangle. Close enough, right? So there's an equilateral triangle, and it says the perimeter is 624. But if all the sides are the same because it's equilateral, we should just be able to do 624 divided by 3 to get each side, right? Which would be 208. So 208 would be each of the sides. So 208, 208. And the height, which is this straight up and down line that I can draw here, is going to be, whoops, that wasn't straight. There it is. So that height there is going to be k root 3, it says. So k root 3. And they want to find the value of k. So this is a right angle the way I drew it. I just split the bottom base in half. So this would be 104, 104, right? And this would be 60 degrees because equilateral, 60, 60, 60. So that means that this would be 30 because it's split in half. It's bisected at the top. So what do we have? We have a 30, 60, 90 special right triangle. And just to go up here again to show you, they tell you how these triangles are related to each other. So in case you forgot, we could just go like this and take this down here with us. Where'd we go? Right there. And this is the picture. So any 30, 60, 90 triangle has these very special related side lengths, right? Where the shorter leg is x and the hypotenuse is double that. And guess what? We have that here. 104 is the shorter leg. Double that is 208. Great. And the question is, how do we get from the shorter leg to the longer leg? Well, it's x root 3, just like here. They have k root 3. But that k is in the same position as our x, which is the length of the shorter leg, 104. And so it turns out that this length here, the height, would be 104 root 3, making our k value 104. Hey, thanks for watching. Let us know in the comments if there's any topics that you want to see a video on going forward. Be sure to like and subscribe, and check out our channel for more content.